Just think about that for a second. 25 years old, one person steps up and corrects the work of generations of brilliant chemists. And we're not talking about some minor correction here. This was a fundamental rewrite of the rulebook for all of matter.
So to really get how huge this discovery was, we need to go back in time a bit. We've got to look at the problem itself, the original periodic table. It was an absolute masterpiece by Dmitri Mendeleev, but it had this tiny yet really critical crack in its foundation. And that was the question hanging in the air for decades. Mendeleev's table was amazing, for sure, but it wasn't perfect. Chemists knew something was off. They just couldn't quite put their finger on what it was.
You know, the rules seemed totally logical, right? Just figure out how much an atom weighs, that's its atomic mass, and then you line them up, lightest to heaviest. And for the most part, this worked beautifully. It grouped elements with similar personalities together, but it didn't always work.
And here is the perfect example of the problem. You've got argon and you've got potassium. Now, based on its properties, argon, which is a noble gas, clearly belongs before potassium, a superreactive metal. But if you order them by mass, whoops, potassium is actually lighter than argon. So to make the table make sense, chemists literally had to break their own rule and swap them. It was this annoying little exception they just had to live with.
And that brings us to our hero, a brilliant young physicist named Henry Moseley. He was working in a top lab and decided to attack this problem from a completely different angle. He wasn't interested in mass or chemical reactions. No, he was using brand new tech to look right inside the atom itself.
His whole approach was just so clever. He'd blast samples of different elements with high-energy electrons. This caused the elements to glow, in a sense. They'd give off X-rays at a very specific frequency. And here's the key. Every single element had its own unique X-ray signature. It was literally like scanning a cosmic barcode to find out what it really was.
So here's what he did, and it's actually pretty straightforward when you break it down. Step 1, he'd bombard an element with electrons. Step 2, he would carefully measure the frequency of the X-rays that came flying off. And step 3, he'd plot all that data on a graph to see if there was some kind of pattern. And let me tell you, he found one.
Okay, this is it. This is the moment everything changes. A simple graph is about to rewrite everything we thought we knew about what makes an element an element.
This was the big aha moment. When he plotted his data, he didn't get some messy, scattered line. No, he got a perfectly straight line. The data points just lined up, one after the other, in perfect formation. It was like nature itself was screaming a secret, and Moseley was the very first person to listen.
So, what did it all mean? The most important, the defining thing about an element wasn't its weight at all. It was the positive charge in its nucleus, the number of protons. He called this the atomic number, or Z. This was the atom's real, unchangeable ID card.
I mean, just look at this unwavering pattern. It was flawless. As you go from one element to the next on the chart, the atomic number goes up by exactly 1. 1, 2, 3, 4. Just a perfect, beautiful staircase. This was the proof. Atomic number, not mass, was the real organizing principle of the universe.
So, armed with this incredible new law, Moseley could go back to that old, slightly busted periodic table and, well, fix it for good.
And the solution was so elegant, so simple, it was genius. He basically said, throw out the old rule. Stop weighing the elements. Instead, just line them up by their atomic number, by how many protons they have. It was a total game changer.
And here's the payoff. Remember our problem children, argon and potassium? Well, check this out. Argon's atomic number is 18. Potassium's is 19. When you use Moseley's new rule, they fall exactly where they're supposed to be. No questions asked. Problem gone, puzzle solved.
But wait, there's more. This wasn't just about cleaning up the past. Moseley's law was like a crystal ball. It didn't just confirm the order of the elements we already knew about. It pointed to gaps, holes in the table, places where new elements had to exist but just hadn't been found yet.
The scientific impact was just massive and immediate, but the human story behind this discovery is every bit as powerful.
4. This number just shows you the sheer confidence of his discovery. Based on the gaps in his straight-line graph, Moseley predicted that there were 4 missing elements between aluminum and gold. He didn't just say, hey, maybe there's something there. He told future scientists exactly where to look. And sure enough, within years, all 4 were found. But, and this is the really tough part of the story, it has a tragic ending. Just 2 years after this world-changing discovery, World War I started. Henry Moseley signed up to serve his country and was killed in action at Gallipoli in 1915. He was only 27 years old. The world of science lost one of its absolute brightest stars, and you just have to wonder what else he would have discovered.
And that kind of leaves us with a final thought, doesn't it? Moseley proved that even our most fundamental scientific ideas can have room for improvement. It really makes you wonder, what facts that we take for granted today are just waiting for the next Henry Moseley, with a new tool or a fresh perspective, to come along and show us an even deeper truth? Thanks for joining me on this one.